this video we're going to look at the redox reactions of the halide ions, and we're going to be thinking about the halide ions as reducing agents and thinking about their ability to be or behave as a reducing agent. So a reducing agent is an electron donor, and halides are reducing agents because they can donate electrons to become halogens. So to complete the sentence above, halides are reducing agents as they can donate electrons and form halogens. So we are going to think about the halide ions as reducing agents, and we're going to see how well they can reduce sulfuric acid. And sulfuric acid has sulfur inside it, and we're going to think about the names of and oxidation numbers of the sulfur in these different compounds below. So pause the video and see if you can name the compound and write the oxidation number of the sulfur next to it. So good. We've got +6, +4, 0 and -2 as the different oxidation states of sulfur, from sulfuric acid down to hydrogen sulfide. So sulfur dioxide, the oxidation state of sulfur is +4, and sulfur dioxide is a choking acidic gas. And then sulfur is a yellow solid. And lastly, hydrogen sulfide is a gas, and it's got a bad eggs smell associated with it. So we're going to see whether or not the halide ions can reduce the sulfur to the various different oxidation states that we've got in the three other sulfur containing compounds. So sulfuric acid is reduced by the halide ion. The halide ion will be oxidized to a halogen molecule, as we saw above. So next, we're going to have a look at this table, which is going to summarize the reactions that we're going to see. And first of all, there are two types of reaction. So we can either get an acid-base reaction, or we can get a redox reaction. Now, if we get an acid-base reaction, we can tell whether or not that's happened or not, because the sulfuric acid won't have been reduced, so there won't have been any change in oxidation state of the sulfur. And in that type of reaction, the role of the sulfuric acid is as an acid. And alternatively, we could get a redox reaction happening, and we'll know when that's happened because the sulfuric acid, or the sulfur in the sulfuric acid, will have changed oxidation number. It will have become less positive or more negative. And in that type of reaction, the sulfuric acid is accepting electrons, so we're going to say that the sulfuric acid is an oxidizing agent. So if we have a look at the first row where we've got sodium chloride, we're going to see whether or not we get what type of reaction we get. Well, you can see we've grayed out the redox reaction. So chloride isn't a strong enough reducing agent. It can't reduce the sulfuric acid. So we just get an acid-base observation, and we see steamy white fumes produced in that reaction, and the steamy white fumes are because hydrogen chloride gas has been produced. If we look at the second row with sodium bromide, we can see that we're going to get both the types of reaction from above. We're going to get the acid-base reaction and the redox reaction. So with sodium bromide, we get the steamy white fumes, this time produced from or observed from the production of hydrogen bromide gas. And we're going to get the hydrogen bromide is then going to become oxidized into bromine, so we would see orange fumes would be our observation, and the oxidation product would be bromine, elemental bromine. The sulfuric acid would be reduced, so we're going to have a product that is sulfur dioxide, but our observation for that would be the choking gas. So we've got a redox reaction, and the star box below is saying when you get asked for an observation, make sure that you give an oxidation observation and a reduction observation. And lastly, with the sodium iodide, we are going to get the acid-base reaction again. So we're going to see steamy white fumes, this time of hydrogen iodide. And then our oxidation product is iodine, and our observation for that would be a black solid. You might also see some purple vapour when the iodine gets warm enough to turn into a vapour. And our reduction products, well, we're going to get three. We're going to get sulfur dioxide, sulfur and hydrogen sulfide. So the observations that we've got there, the choking gas for sulfur dioxide, yellow solid of sulfur, and then the bad eggs gas of hydrogen sulfide.